The next credits section, Sustainable Sites, is Site Development, credits 5.1 and 5.2. The intent of these credits is to conserve existing natural areas, restore damaged areas, provide habitat space, and promote biodiversity. SS Credit 5.1, Site Development, Protect and Restore Habitat, has 1 point available for new construction, schools, and core and shell. There are 2 options to achieve this credit. Option 1, Greenfield Sites. Protect by limiting site disturbance beyond 40 feet of building perimeter, 25 feet of constructed areas within permeable surfaces, 15 feet of a primary roadway, curbs, and of utility trenches, 10 feet off walkways, patios, surface parking, and 10 feet for utilities less than 12 inches in diameter. In LEED version 4, draft 4, they replace setback requirements with preservation standards, and soil requirements include disturbed, compacted soils. If trying to achieve this credit, it's important for a contractor to delineate where site construction waste and recycling is going to be stored in order to maintain areas that are going to be left in their native indigenous way. Pre-planning is important to low-impact design and construction. SS Credit 5.1 Option 2 is previously developed sites, which means keep 50% of the site green, excluding the building footprint. There's innovation design credit available for 75% of the space being green space. Or you can calculate this with 20% of the total site, and that would be including the building footprint. Innovation design is available if 30% of the site is left open, including the building footprint. This is an example of where LEED version 4, draft 4, has proposed just upping the ante on existing credit requirements, where 30% would become the credit requirement, not an innovation design point. To achieve this credit, you can include a green roof if the project earns SS Credit 2, Development Density and Community Connectivity, and if the plants are native or adapted to provide habitat and promote biodiversity. Turf, grass roofs would not be accepted. It's important to practice integrated design for these type of sustainable design and construction projects, including landscape architects, roofers, people specialized in horticulture, and the owner, to make sure that all goals are met to help the life of the roof through a green roof, not just achieving this credit, but a life cycle cost analysis of how it could actually improve the building over time. Sustainable Sites Credit 5.2, maximize open space, the second credit related to site development. There are 3 options. Option 1 is if there is a local code for open space, then the open space should exceed local code by 25%. Option 2, there is no code, which could be campuses or military bases, where open space is to be same size as the building footprint to meet the credit criteria. Or for option 3, if there's a local code but 0 open space requirement, then open space should be 20% of site area. LEED version 4, draft 4 provides opportunities for social interaction, passive recreation, and physical activities. Also, the green roof option can only be counted if it's physically accessible by the building users. There are many roofs you could see in Portland from other buildings, but you never gain access to when you're actually in those buildings. I think this would be a great addition. There's also talk about creating activities in buildings where people could actually maybe even jog around on their lunch break on top of a building in some sort of track. For all options, once again, a vegetated roof can count towards the credit if SS credit to development density and community connectivity is achieved. Another part of the site that can be included is pedestrian-oriented hardscape, but that's only if it meets a minimum 25% open space that's vegetated. And wetlands can also be considered open space. This could also include naturally designed ponds. If the side slope gradient is an average of 1 to 4, any more than that, it'd be like a crater. Example of urban open space could include pocket parks, accessible roof decks, plazas, and courtyards as well. This also has synergy with stormwater management. More example of green roofs integrated with design. It's important to consider all layers of a green roof and all the different options of how you can apply a green roof. For existing building, a modular system may be preferred for ease of installation, possibly even being able to go up on an elevator to avoid crane costs. And also make sure that there are multiple layers of protection for root barrier and protecting the roof. This also adds to the performance of the roof for energy efficiency, which has synergy with Energy and Atmosphere Credit 1, Optimizing Energy Performance. The open space credits we just went over. Stormwater management through evapotranspiration from the green roof, and also reduction in heat island effect by adding more green space. The various layers could include vegetation, some sort of growing medium, a drainage area, membrane, and of course the structural support for the roof, which may need to be increased for the weight of the green roof, depending on what's being grown, the depth of the soil, therefore the weight of the green roof. Once again, integrated design facilitates this process in making good decisions that are going to help the life of the building. There's incentives for green roofs in many states. Oregon, for example, offers $5 per square foot for an eco roof. It's important to check with your local jurisdiction to see if there are any incentives available. Some areas are actually mandating green roofs. In Chicago, for example, every government building has a green roof. Tokyo is growing their requirements as well. It's this massive scale adoption that's going to make the impact necessary to reduce our impact on our climate. Example of a green roof is on the California Academy of Sciences rooftop in San Francisco. It's substantial in size. It covers 400,000 square feet. And it features an undulating 2.5 acre living roof. Within that, there are porthole-like skylights. This helps with energy efficiency within the building as well to reduce the amount that electric lighting is used. And this rolling landscape emulates the park that existed before the building, lowering the impact of the building on that ecosystem. Sustainable sites, credit 6.1 and 6.2, both relate to stormwater management and design. Good stormwater design mimics natural hydrology. Too often we see water puddling and overly exhausting our municipal resources and systems. LEED version 4, draft 4, now has a credit titled Rainwater Management proposed that would combine quantity and quality control, which are the two separate credits in version 3 for stormwater section, and incorporates more site-specific criteria for frequent low-intensity events and additional zero lot line options for urban developments. Developments have a large impact on stormwater management. On natural ground cover, you get an average of 25% deep infiltration depending on your location, soil type, and 25% shallow infiltration, so 50% total infiltration. Only 10% of rainwater becomes stormwater runoff, and 40% is evapotranspiration from vegetation. This helps our natural ecosystem, opposed to development that has 75 to 100% impervious surface, like many areas, where there's only 5% deep infiltration, 10% shallow infiltration, which is less than half of what you see in the natural ground cover. 55% results in stormwater runoff. There's only 30% evapotranspiration. So gradually, the more impervious surface you have, the less infiltration that happens that feeds our natural aquifers and groundwater table. U.S. is going to see many water shortages over the next 5 years, which I think is going to draw more attention to how we use our potable water and how we manage our stormwater. And LEED version 4 is taking that into consideration during this comment review period. SS Credit 6.1, stormwater design, is for quantity control. The intent is to limit disruption of natural water hydrology by reducing impervious cover, increasing on-site infiltration, and managing stormwater runoff. Option 1 is for largely undeveloped sites. Existing imperviousness is less than or equal to 50% in this case. And you must implement a stormwater management plan for the 1 and 2 year 24-hour design storms, where the post-development peak discharge rate and quantity is equal or less than the pre-development peak discharge rate and quantity. Stormwater is a major source of pollution for all types of water bodies in the United States, including the river I grew up on. Increased stormwater runoff can overload pipes and sewers and damage water quantity. Or in our case, there was combined stormwater and sewer, and they would overflow into the river, which is unhealthy for both humans and animals in the ecosystem in our rivers. Roads and parking lots produce stormwater runoff that contains sediment and other contaminants such as atmospheric deposition, pesticides, fertilizers, vehicle fluid leaks, and mechanical equipment waste. This can all be prevented with better stormwater management and low-impact design. Just showing the importance of what these LEED credits are actually addressing. They're much more than just a checklist. Option 1, continued. The other option is to implement a plan that protects receiving stream channels from excessive erosion via a stream channel protection strategy. You must describe site conditions, measures taken, and controls implemented. Implementation and documentation would include a civil engineer in the design submittal, where they would need to calculate rates and quantities based on the surface characteristics of the site and data on storm event frequency, intensity, and duration. They must provide pre- and post-development site runoff rates and quantities proposed in a narrative. Option 2 is for largely developed sites, where existing imperviousness is more than 50%. Must implement a stormwater management plan for the 2-year, 24-hour design storm, and it must result in a 25% decrease in the volume of stormwater. There's an innovation design credit available by documenting a comprehensive approach to capture and treat stormwater runoff above and beyond the credit requirements. To estimate runoff rates and volumes, there is a rational method that is often used. You can find resources at the U.S. Natural Resource Conservation Service website, which is used typically to calculate runoff quantities. Option 2, we see a letter template for Lead Online. This is just a sample of what's included in the letter templates that are uploaded for credit compliance verification. See pre-development site runoff rate in cubic feet per second, pre-development site runoff quantity, and then post-development site runoff rate and post-development site runoff quantity. And because Lead Online now uses Adobe Lifecycle, this will give you the percent reduction in post-development site runoff rate and the percent reduction in post-development site runoff quantity. Strategies include rainwater harvesting, which means you're reusing the stormwater for non-potable water purposes, such as flushing urinals and toilets. Also custodial applications, cleaning sites, cars, or the building. And also building equipment. This could be makeup water for your HVAC equipment. Underground parking, which also has a synergy with heat island effect and open space. Clustering and development, also synergy with open space, similar to the strategy to limit building footprint, add more density. Pervious paving, you can see water infiltrating through the porous paving. And green roofs, which, as we discussed, have many synergies within the LEED rating system that have a positive effect on the sustainable design of a development, including reducing stormwater runoff, reducing heat island effect, increasing open space, especially with native or adapted species, and also helping with optimizing energy performance through insulating the roof, if it is done correctly. Implementation and design is critical. Just putting turf, grass on top of a roof is not going to afford all these benefits. Once again, an integrated process with multiple team members is critical in making the best decision on what type of green roof should be applied to your project. Other methods for minimizing the impact of parking could include a grass paved system for parking aisles and a gravel paved system for driving aisles. This could have other benefits, including economic benefits in reducing the need for extensive drainage systems, manholes, catch basins, and oil and gas separators, depending on your jurisdiction's codes and requirements. So related credits, BSS Credit 6.2 Stormwater Design, 5.1, 5.2 Site Development, 7.1, 7.2 Heat Island Reduction, Water Efficiency Credit 1, Water Efficient Landscaping. The synergy could come from rainwater harvesting. Water Efficient Credit 3, Water Use Reduction. So we could use rainwater harvesting for both irrigation and for flushing toilets. Benefits is increasing on-site infiltration, decreasing impervious surfaces, and the potential for harvesting rainwater.